Hello students, how are you? You are joining with your ICT lesson. This is the video for grade 8 and 9, the introduction to programming. I think programming is a new word and I think it may be very interesting for you. Okay students, let's move to our lesson. What do you know about programming? Okay students, do you know there are different programs in our computer? Those programs are called softwares. Softwares are made with different programming languages. Also, these softwares are created by software engineers. Okay, if we're going to make a software, first we have to understand what is the task and what is the purpose of the software. Okay, there should be a problem or there should be a solution. If there's a problem, there may be a solution. That solution is the program or software. The problem is what is the specific task. Okay, I think it is not clear for you. If we're going to learn about creating softwares, you have to understand the difference and what is the relationship between a software and a problem. Okay, students. When we are going to create a software, as I mentioned earlier, there should be a specific task. We identify that specific task as a problem. Okay, we may meet with different types of problems in our day-to-day lives. As a solutions, we create softwares if that problem is related to computer. Okay. Before going to solve complex problems, we can divide them into small segments. That means that problem can be divided into small problems. Then we can analyze it and examine the solutions. That problem that is called problem analysis. That means dividing the problem into small segments and examining it is a called problem analysis. Because of this, dividing the problem into small segments, we can find the specific solutions for each segment. Here, this is the way we analyze the problem. There's an invoice that was taken from ABC bookshop. There are 3 items with amounts and unit prices and total prices. In pink color, you can see inputs, and in green color, you can see process, and in blue color, you can see outputs. Okay, there's a book with 200 pages and unit price is 150. Then price is 150. Then there are 4 books with 480 pages and unit price is 55. Then the total price for 80 pages are 80 pages books is 220. Then there are 3 carbon pens. Unit price of a pen is 50 rupees. Then the price of 3 carbon pens are 45. Then 415 is the total price for these items. Here, this is the way we analyze the problem. First, we analyze the input items. In that invoice, the item description, number of items, and unit prices are the inputs. Then the process. For an item purchased amount, the number of items into unit price. Then the total bill can be calculated with total price of all items purchased. Then the output is the amount we paid. Okay, understood this? Let's move another example. Okay, before going to another example, see this. In order to develop a computer program, it is essential to identify the inputs, process, and output. Here, the inputs means necessary items for a solution, for example, data. Then the process means the method to arrive at the solution. That means the method we arrive to the solution. Outputs are the solutions related to the problem. That means information. Okay, this is the process and this is the way of analyzing the problem. Next example, find the year of birth when a person's national identity card number is given. Okay, this is the national identity card number and in red color you can see the birth year. Input means national identity card number. The process means select the first two digits in the identity card number. From these first two digits, you can identify the year of birth of a certain person. Second example, find the cost of purchasing 5 pens. Here you have to input the price of 1 pen and process means price of a pen into 5. That means amount of pens. Output is total amount. Okay, let's move into another segment. Here, algorithm. I think this is a new word for you. Let's move to this algorithm. Algorithm means a method that includes all the steps of solving a problem. In order is known as algorithm. Here, in order is very special. This method includes all the steps in order. Example 1. Step to create fruit salad. Okay, these are the steps of making a fruit salad. You have to find fruits, then wash them, then cut into small pieces, and add sugar and mix them and serve it. These are the specific steps of making a fruit salad. This is called the algorithm of creating a fruit salad. Then another algorithm for making a chocolate cake. There should be start and end like this. Then you have to include the steps. Here you have to clean and wash the baking tray and other bowls. Then dissolve chocolate, mix wheat flour and baking powder. You have to beat them and add sugars and add dissolved chocolate, add milk, put the mixture into a baking tray and bake it. Let it cool after baking and you can decorate it. So students, you have to examine, you have to analyze these things. Next, another algorithm to find the area of a rectangle. Okay, now think, what is the way of calculating the area of the rectangle? Here you can see area means length into width. That means start, you have to get length and width, then process and get the area of the rectangle and end. You have to include here step 1 and last step as a start and end. Okay, let's move on to another part, flowchart. Let's see what is a flowchart. A flowchart is a graphical representation of the algorithmic steps. Graphical representation. Let's see what is graphical representation. Graphical representation means you have to mention the steps with graphically, like this. Used to indicate the start and the end from this symbol. Then used to indicate the input and the outputs by this symbol. Here, used to show an action or a process. For example, adding x one by one to the mixture and area equal length into width, like that. Then this is the decision. There are two ways of taking decision, yes or no. For example, used to indicate an instance of decision making. That means, for example, if the first number is greater than the second number, yes or no, like that. Here, these arrows indicate the direction of data flow. Okay, can you understand this? Okay, students, this is an example for a flow chart. What is problem? This is a problem. That means making a fruit salad. Here, see, this green color indicates the input and output. Getting various foods and serve the prepared foods. Then these rectangles indicate the process. That means washing fruits, cutting fruits, then put them into bowl and add sugar and mix like that. There's another example for flowchart. This flowchart for finding the area of a rectangle. Okay, as we learned earlier, remember what is the way of making the area of the rectangle? That means you have to multiply length and width to obtain the area. Here, this is the process. Then inputs. First, you have to mention start, then inputs. Get the length of the rectangle, then get the width of the rectangle, and you have to process it and find the area as the output and end. Okay, now we are going to move another special segment, that means control structures. Here, control structure is a block in a program that analyzes variables and chooses the direction of flow of the program. That means these are block in a program and it analyzes variables and the direction of the flow of the program. Let's see. There are three control structures: sequence, selection, and repetition. Let's see each of them. Okay, this is the sequence. Let's see what is that. The steps are carried one after the other from the beginning to the end in particular consecutive order. It is called a sequence. That means the steps are carried one after the other from the beginning to the end in a particular consecutive order. This is the example. Finding cost of 5 books. There should be a start and end. Then you have to input the price of a pen and the process total equal price of a pen into 5. Then display total as output and end. Next, selection control structure. That means you have to take decisions here. Selection decides which steps are executed depending on whether a condition of an algorithm is satisfied or not. Here, if there's a rain, he thinks, what is the decision? Go to library or go to playground? This is selection. Okay, this is the control structure, yes or no. And is it raining day to day? If it is yes, and if it is no, like that. Here, this indicates the above as a flowchart. Start, find out the weather condition. Then, is today rainy day? If it is yes, to go to the library. We take this output. If it is not raining, okay, if it is not raining, to go to the playground. Then you can end the program like this. Okay, this is a small game. I think you all know about this. Making decisions and playing snakes and ladder game. This is the flow chart for that. Here you have to toss the dice. This is considered as a process and get the value. Move the counter forward according to the value of the dice. This is taken as inputs. Then there are decisions. Did you reach the bottom of the ladder? If it is yes, move the counter to the square at the top of the ladder. If you not reach the bottom of the ladder, you can ask again, did you reach snake's head? No. If it is no, then the end. If it is yes, move the counter to the tail of the snake. Next, another example. Awarding 10 marks to the correct answers. Here start and end, then ask the question as input, obtain the answer as input. Is the answer correct? You can award 10 marks and if it is considered as output. And if it is no, you end the program and you cannot award 10 marks like that. Okay, another example. Here I think you can understand. Find the large number from two unequal numbers. There are two unequal numbers and can understand this. Okay, then A is greater than B. This is the way you have to take decisions. If A is greater than B, if it is yes, show A is greater than B. If it is no, show B greater than A. Okay, last control structure. Repetition. Repeat. Can you remember the word repeat? Repeat means occurring something again and again. Here, repetition means it is about an action getting repeated again and again. Here, displaying numbers from 1 to 5. This is repetition. This is the flow chart. First, you have to begin and you have to initialize the number equal 1. Then you have to take decision. Is the number 5 or less than 5? If it is no, you can end the program. If it is yes, you can show the number. Here, if we take as example number 1, then try to understand, is the number 1, it is equal to the 5 or less than 5? Okay, 1 is 1 less than 5. Then you can show the numbers here 1. Then you have to add 1 to that 1. 1 means 2. Then again go to there. Here 2. If 2 is less than 5, yes. Then again here it shows 2 and you have to add 1. That means 2 plus 1 means 3. Again you go to this decision. Okay, now there's 3. Again we can ask, is the 3 equal or less than 5? Yes, 3 is less than. Then again show the number as 3. You have to add 1. Then 3 plus 1, 4. Again we can ask if 4 less than 5 or equal. Yes, it is less than. Then again you have to show the number as 4 and you have to add 1 to that 4. Then 5. Is the number 5 or less than 5? Yes, the number is 5. Then again you can show the number as 5 and you have to add 1. 1. 5 plus 1 is 6. Is the number 6 equal or less than 5? No. 6 is greater than 5. Then end. This is the end. Okay, this is the simple example for repetition control structure. Okay, there's another example. A water pump filling water into a tank. The pump is operated until the tank becomes filled. Here's the begin. Then how to instruct to operate the water pump. Water flows into the tank process. Is the tank full? Yes. Then you have to instruct to stop the water pump. If it is no, you have to again fill the water like that. Another example, marking attendance of students. Here's the begin and you have to call out the student's name. Is the student present? Yes. Then mark 1 for present. Any more names to be called? Yes. If it is yes, again go to that. If it is no, in the program. Here also you can see if it is yes, is the student present? No. Then you have to put 0 for the absent. And if he is present, you have to put 1 for the presence like that. Okay, students, I think you have get small knowledge about programming into your level. That means grade 8 and 9. In grade 11, you can learn more than about programming and you can create and learn some programming languages also. Okay, today I'm going to end this programming lesson. Let's meet with another lesson again with another day. Okay, thank you and have a nice day.